Hello, everyone, and welcome to today's lab session. Today, we are diving into the essentials of static routing. Throughout this session, we'll explore the foundational concept of static routing, its significance in network configuration, and practical steps to implement it effectively in our lab environment. So, let's get started and delve into the world of static routing. But before you begin the session, make sure you subscribe to our channel and click on that bell icon so that you will never miss an update from us. Before diving into our main topic, static routing, let's first get an overview of what routing is. Routing is the fundamental aspect of networking. In simple terms, routing is like finding out the best way to deliver a message from one place to another. Just like you choose the fastest route on a map to get somewhere, routing decides the quickest path for data to travel through a network of connected devices called routers. These routers determine how data should move, ensuring it reaches its destination smoothly and without delay. Alright, let's dive into the different types of routing: static routing, dynamic routing, and default routing. Let's take a closer look at each one. First up, we have static routing. Static routing is quite straightforward. It involves manually configuring route in the routing table. Imagine it like setting a fixed path for your daily commute. Network administrator enter these routes and they stay put unless someone manually changes them. This method is simple and stable, making it ideal for small or less dynamic networks. Next, we have dynamic routing. Dynamic routing is a bit more flexible and intelligent. It uses routing protocols to automatically discover and maintain routing tables. Routers exchange routing information with each other, allowing them to adapt changes in the network. This method is great for large or more complex networks, where routes can change frequently. Lastly, there is default routing. Default routing acts as a catch-all. It involves configuring a router to forward packets for which it doesn't have a specific route in the routing table. This is like having a default direction to follow if you are not sure where to go. Typically, it's used to send traffic destined for remote networks to a single next-hop router. This method simplifies routing in environments where you don't need to know all the specific paths. Okay, so we are focusing on static routing today. We choose static routing because it's ideal for simpler, smaller networks where routes don't change often. It's straightforward to implement, require minimal resources, and provide a high level of control and predictability. This makes it a perfect choice for our current network setup, where we need stability and simplicity over the dynamic adaptability that other routing types offer. So let's dive into static routing and see how we can configure it effectively. Static routing is a way to direct data in a network. Unlike dynamic routing, it doesn't rely on protocols to adjust route automatically. Instead of letting the network figure out the best path for data automatically, a network admin sets the path manually. This means the routes are fixed until someone changes them. In an IPv4 network, a static route tells the data packet how to travel from one place to another. It uses three key pieces of information: destination IP address, where the data is going; subnet marks helps to identify the network part of the IP address, and the next hop IP address or exit interface, the next stop for the data on its way to the destination. One major downside of static routing is that it needs regular updates. If a path fails, the router won't automatically find a new one. The network admin has to manually set a new route, which can take time. However, static routing is still useful, especially for small and stable networks where changes don't happen. Let's take this diagram as an example. Imagine you have a network with 5 routers and all are connected. Let's say you want to send some important data from router 1 to router 3. You have set up a default route where router 1 sends the data to router 2 and then router 2 forward it to router 3. This is called static routing. You manually tell the routers where to send data packets. But what if router 2 suddenly goes offline due to some glitch or maintenance? Router 1, being the dutiful sender, doesn't automatically know how to reroute the data to reach router 3 because it's only programmed to go through router 2. This is where the network administrator steps in. They need to step up and manually configure a new path for router 1. By doing this, they ensure that the data from router 1 find its way to router 3 through an alternate route that's still operational. So while static routing is great for setting predictable path in a network, it relies on human intervention when something unexpected happens like a router failure. This ensures that your data continues to flow smoothly from one point to another, even when the network faces challenges. Okay, now let's discuss the objective of the lab. The primary objective of configuring IPv4 static routing is to manually specify the path that network traffic should take to reach a particular destination network or subnet. Unlike dynamic routing, which automatically adjusts routes based on current network conditions, static routing requires the network administrator to manually configure the routes. Before starting our lab demonstration, let's consider a scenario. Astra Incorporation, a company specializing in high speed wireless products, operates a factory in San Francisco with two buildings, one for production and one for quality assurance. Both buildings are currently facing issues with transmitting and receiving data, despite being connected to the ISP router. Their goal is to establish static routes that allow seamless communication between PCs in both buildings and ensure connectivity to the ISP. This will help resolve their current data transmission issues and maintain efficient operations. Okay, so these are the requirements that outlines the essential IP configurations for setting up an IPv4 static routing across the network infrastructure. You can pause the video to look at these requirements because we'll using these in our lab. This is sample topology that illustrate the network configuration for the production and quality assurance building connected through router 1 and router 2 respectively, and the ISP router serves as the gateway to the external network and manages traffic routing between internal networks. There are a few ways you can create this kind of topology. Popular platforms include Cisco Packet Tracer, GNS3, and EVENG. Each of these tools has its own strength and can help you simulate different network environments. In this video, we'll walk you through how to set it all using Packet Tracer. It's a great tool for visualizing and experimenting with network configurations. Alright, let's quickly move on and start our lab demonstration. We'll begin by setting up our network topology. We are gonna build our topology on Cisco Packet Tracer. So here we need to take three routers to simulate different network segments. One for the production building, one for the quality assurance building, and one representing the ISP. So here I'll take three routers using Cisco 2811 series to provide internet access to both the production and quality assurance building. Okay, now I am using two switches to manage the network traffic within each building, one in the production building and one in the quality assurance building. Now let's add two switches. So here I am going to choose 2960 series. We will place each one in separate building. Now it's time to add PCs in the building. So here I'll add two PCs in the production building and I'll simply put two PCs in the quality assurance building. Now I'll take the name of each device to make it look better. Okay, it's done. So I'll go to the production router and add a module on each router that helps to connect each other. So first I'll power off router 1. Then I'll install the NM1E module to provide additional Ethernet interfaces, allowing more connection and flexibility in our network setup. Once installed, I'll power on the router And I'll repeat these steps for the other routers to ensure all are equipped with the necessary interfaces for our network configuration. Now it's time to connect these devices through Ethernet cable. As you can see, here are multiple options like console, copper straight through, copper crossover. So here I'll simply choose copper straight. We are choosing copper straight through cables to connect our devices because they are the standard for linking different types of network devices, such as PCs to switches and switches to routers, ensuring compatibility and ease of use. By using copper straight through cables, we simplify the network setup, reduce potential errors, and ensure reliable connectivity, which is crucial for efficient communication between the production and quality assurance building and out to the internet through ISP router. So here I'll connect PC1 and PC2 to the production switch through a fast Ethernet port and then connect the production switch to the router. Similarly, I'll repeat these steps to connect the quality assurance building. Okay, now we connect these three routers with each other. So we've successfully connect devices with each other. Now it's time to add some visual elements to our topology. First, we'll draw a box with a black outline and click on Fill Color option. Okay, I'll click here and select a gray color and draw a box around production router, switch and two PCs. This box will represent the production building. Okay, let's draw a similar box for quality assurance building. Now let's add a label on each building. On the first box, I'll take the name Production Building. And on the second box, I'll name it Quality Assurance Building. For a finishing touch, make a large orange outline box to make the overall layout more visually appealing. And add the company name Astra Incorporation Company. Now I'll simply add a label of this lab. So here I'll type configure IPv4 static route. And now finally add a black box. Now let's label each network on the topology to make configuring devices easier. Between production router and quality assurance router, we'll use the 172.16.3.0 network with a /30 subnet marks. From the ISP2 production router, we'll use 172.16.1.0/30 network. From the ISP2 quality assurance router, we'll use the 172.16.2.0/30 network. From production router to PC1, we'll use the 192.168.100.0 network. And lastly, from quality assurance router to PC3 and PC4, we'll use the 192.168.200.0 network with a /24 subnet marks. Our network setup is completed. Now we'll start our configuration and configure each device step by step. Let's start with the PC. For each PC, we need to set the IP address, subnet marks, and gateway. Let's start with configuring PC1. Click on the desktop, then click on IP configuration. You will notice it's set to static by default. First, let's understand some key terms that we need to put here. A subnet mask is a 32-bit number that separates an IP address into network and host portion, indicating which part of the address identifies the network and which part identifies the device within that network. This helps in efficient routing of packets within the network. Next, a default gateway is like your network exit door. It's a device, typically a router, that allows devices in your local network to communicate with devices in other networks. It's essentially the access point for data to be sent outside your local network. Now we'll assign a specific IP address to PC1. We'll use 192.168.100.10 for PC1. Enter this IP address along with the subnet marks 255.255.255.0. Okay, now let's set the default gateway to 192.168.100.1. So PC1 is configured and ready to communicate within the network. Similarly, I'll configure other PCs. Okay, so our PCs have configured. Now let's start by setting up first switch in our production building. First, we need to access the switch and enter privilege exit mode command by using enable command, which gives us access to high level configuration setting. Next, we'll enter global configuration mode with using configure terminal command. Now let's set the host name of our switch to production switch. Okay, now let's configure VLAN1 that allow us to manage the switch remotely by assigning an IP address. Okay, so let's enter interface VLAN1 and the IP address 192.168.100.2 with the /24 subnet marks and no shutdown command. Okay, now we exit the interface using exit command. Now it's time to configure the Ethernet interfaces as access port to connect end devices like PCs. Okay, now we'll enter interface range FS0/1 to 2 command. We can specify the range as 1 to 2 because our port numbers are 1 and 2. So that's why I write that interface range. So this command allows us to configure multiple interfaces at once. By specifying a range of interfaces, we can apply the same configuration settings to all these ports simultaneously, which is much more efficient than configuring each port individually. Then we'll enter switch port mode access command. This command sets the specified interfaces to access mode. Access mode is used to connect end devices like PCs to the switch. In access mode, each port is assigned to a single VLAN, making it straightforward to manage traffic and maintain network segmentation. This is essential for ensuring that devices connected to these ports can communicate correctly within their designated VLAN. Okay, now I'll enter no shutdown command and exit command to exit that interface. Okay, now I'll similarly configure quality assurance switch as well. So we've successfully configured these two switches. Now let's start to configure production router for the production building. Let's start by enable command and enter configure terminal. Set the host name as production router. Right. Similarly, configure the fast Ethernet 0/1 interface by entering interface FA0/1 and then type IP address. Okay, now let's enter IP address 172.16.1.2 with /30 subnet marks and type no shutdown command to activate the interface. Enter exit command. Similarly, I'll configure the fast Ethernet 0/1 interface by entering interface FS0/1 and then type IP address 172.16.3.1 with /30 subnet marks and no shutdown command. Finally, the last port to configure is Ethernet 1/0. So we'll just enter interface E1/0 and the IP address 192.168.100.1 with /24 subnet marks and enter no shutdown command. So exit that interface. Similarly, I'll configure quality assurance and ISP router as well. Okay, so our routers have configured. Now that we have configured the interfaces, let's set up the static route for each router. We have set up a static route on production router by using the command IP route 192.168.200.0, 255.255.255.0, and 172.16.3.2. This command set up a static route for the 192.168.200.0 network via the next hop IP address. It ensures that all traffic destined for the network is correctly forwarded through the specified next hop. Next, we have set up another command on production router. So we simply write IP route 172.16.2.0 with slash 30 subnet marks and 172.16.3.2. This command establishes a static route for the 172.16.2.0 network, defining the subnet marks and directing traffic via the next hop IP address. This configuration ensures that packets intended for devices within the network are routed efficiently through the network infrastructure. Then we'll type exit command to exit global configuration mode. Now we will use show IP route static command on each router to confirm static route entries. So I'll type this command on each router one by one. Okay, first I'll go on production router and type show IP route static. So here we found two static routes. Okay, now write this command on quality assurance router. Enter show IP route static. And we found two static routes. Now I'll check on ISP router by entering show IP route static command. So here we'll find three routes. Okay, now let's open the command prompt on PC1 and let's verify our configuration by pinging between devices. First, from PC1 in the production building, I'll ping PC2 to ensure intra-building connectivity. So here I'll type command ping 192.168.100.20. So as you can see here, the connection is successful. Okay, now let's type another command to check connectivity between buildings. Type ping 192.168.200.10. So yeah, we receive a successful reply that confirmed communication within the production building. Okay, we will be checking by sending packets from PC1 to PC4 and it's successfully received. Alright, let's try from PC2 to PC3 and again the status is successful. So that's it, we've successfully configured the devices and set up static routing. This will ensure that all our network can communicate with each other through the specified routes. That concludes our session for today. Thank you for watching this video. If you found this video helpful, don't forget to give it a thumbs up and share it with your colleagues or friends who might benefit from this information. If you have any questions or topics you'd like us to cover in future videos, feel free to leave a comment below. Your feedback is invaluable to us.